welcome to the Data Engineering Conference Australia. My name's Dom Colyer. I'm going to be your host for this talk about building a code-generated data platform. I'm a sales engineer at Fivetran here in Sydney, and my background for the last 7 or 8 years has been in building data warehouses on-prem and also in the cloud more recently. So this talk is really going to be pointed at data engineers, ETL developers, or business analysts, and really anyone who's involved with building data structures for BI or ML reporting needs. So let's just jump in. A little bit of context around today's talk, and it's going to be about the modern data stack and how we streamline and automate as much of the modern data stack as we can. So the modern data stack is a best of breed approach to build a modular, agile, and reliable data platform, and it generally consists of 3 parts. We have a cloud-native ELT tool such as Fivetran to land all our data reliably and consistently. A powerful cloud data warehouse such as Snowflake, Databricks, BigQuery, or Redshift. And an interactive BI tool to surface the insights that we're going to pull from that data. So as I said, we're going to talk about automating all these 3 pieces of the puzzle and really the common data foundations that we see inside of these data warehouses. So from building data warehouses myself and being involved with a lot of them, I've really found that there's generally a few common layers, and that's a landing or staging area where we land all the data raw, a history or time series layer, where we persist the data and the evolution of that data over time, and then a modeling or reporting layer, and this is where we have our Kimball, our data vault, 3NF, or whatever reporting structures we need for our downstream processes. So as I said, these structures become very common and repeatable across industries and technology stacks. And therefore, we can clearly define a set of structures and rules around these layers. And that lets us build code automation to manipulate those structures and rules. Now, why do we want to use code automation and what's the point of it rather than just building it out by hand? And it's because these become complex and tricky environments to work in. And as you can see here, our data engineers are generally available from getting that data from source to our data warehouse and maintaining those pipelines. And then our data analysts for building those curated data models and surfacing those insights to the reports for our business users. And each of those take time by themselves, and then eventually we end up going back to data sources, either with new data sources or to get more data. And our engineers follow the same loop, and our analysts, again, go through the same loop. And this quickly balloons out to weeks or months for these constantly evolving data warehouses. So why we're trying to build those common data platforms, and then why we should use automation, because I believe these become repeatable and standardized processes that we can put in place to help us build these out. And the benefits of automation are really around the speed and the agility get greatly increased, and we have a smaller delivery cycle on our data platforms. We get inbuilt governance and controls, such as standardized naming conventions and data types. Lineage and metadata gets built in, so we know where the data came from, who's touched it, at what time, and what it's done, whether it was an insert, update, or a delete. Our code logic becomes standardized and reproducible at scale across all layers of our platform. This then unlocks standardized workflows, and the movement of data becomes standardized, so we know what everything's doing is playing by the same rules. We reduce human error in terms of copy and paste errors. We start to unlock CI and CD workflows inside of our data platforms as well. And we've probably all built a fair few of these, and let's be honest, this is a bit more fun. It gives it a new flavor into our projects. So what do we need for code automation and to automate this modern data stack? It boils down to 3 main things. We need metadata, or source to target mappings. And this is what tables we're going to move, what columns inside those tables, the data types, what primary keys we have, and other associated metadata around that. We need data structures. So automation is definitely easier when we have one-to-one relationships between those tables. But all our structures need to be clearly defined and adhere to naming conventions, because we're probably going to reference tables in the code or objects in the code that aren't actually built yet. And the third, we need code patterns. And these are really the templates we're going to apply when we're doing the automation. And these can be upserts, they can be deletes, they can be merges, and then right up into our dimensions, facts, hub links and sats, or whatever we're building downstream. That'll be the patterns that we're going to apply. So the solution, as I said, I believe, is to automate this. And automating 2 ways. Fivetran is going to automate the ingestion of data for us. So it's a plug and play as you go ELT tool, and lands all that data in our database for us. And then once we've landed that data in our staging layer, that unlocks an information schema. And essentially that's the first part of our source to target mappings. I will say, obviously, Fivetran is a great tool, but if you're not using it and you're using any other ELT tool, once you land that data, you're still going to have the information schema. So this is completely dependent from here on out, as long as we get an information schema. And then what I've built here is a few views, and this is where the automation is going to happen. So we're going to automate structures off that metadata, and that's going to be a staging view, and that's going to give us some governance lineage and unlock a CDC mechanism. We're going to have a history table, and that's where we're going to store and persist this data and its evolution over time. And then these two here are our patterns. So we're going to have an insert and a merge pattern, and the insert's going to move the data into our history table, and the merge is going to update the is current rows and the non-current rows, so we keep track of those. On top of that, we're going to have a history layer with the current records only for kind of ODS and BI purposes. And then we'll have the history table, which will have all the evolution of that data. So let's jump into a demo. Let's have a look what it looks like. And all the code I'm going to show you now is available on my GitHub link that you have here. So let's jump right into that demo. And this is Fivetran. Fivetran is an ELT data pipeline as a service product. It needs a destination, and as we saw in our architecture, we're going to use Snowflake for this demo, and I've authenticated into a Snowflake instance now. And we're going to quickly set up a connector. So we're going to use a SQL Server for this instance. And we're going to give it a schema name. And this is what it's going to be called inside our Snowflake database. Let me just connect up here with our username and passwords and our sales database. So while this is running some connection tests, as I said, Fivetran is a ELT data pipeline as a service. Now we use databases as a service, such as a Snowflake. So why not use a pipeline as a service tool as well? And what Fivetran is really good at is connecting to all your data silos and centralizing those in a cloud data warehouse for you. It has a multitude of connectors. Let me just select this certificate. It has a multitude of connectors across four main areas, and that is applications, so things like your Salesforce, your Adobe, Google, and Facebook analytics and ads, your Marketos, your NetSuites, and your Shopify's, things like that. It connects to most databases, such as SQL servers, Postgres, MySQLs, and Oracles. And then it connects us to file storage, so Azure S3 or Google Cloud Storage and most of the other flavors of cloud storage that you can think of. Fivetran will connect to, and it will pull all that data out and load it into a destination for you. Now, what's good about Fivetran is it is a set and forget model. So once you connect those connectors up, Fivetran will handle everything else. It'll load all your historical data, and it will do all your schema detection for you, so your pipelines will never break. It will automatically add columns and new tables when they get added and keep the pipeline up to date so that data is always flowing. And that's going to be our first layer of automation. So we're going to use this to automate all our work, which will generally take us weeks to months to land all that data inside our Snowflake database. So you can see here, I'm going to review the schema. And this is where we can select which data we want to pull from that source. So this lets you deselect and select columns, and also lets you go right down into, tables and right down into a column level. So I'm going to take off this test table, and I'm going to bring through these three tables here. Once that's done, obviously you can see we have some nice status pages and user actions, but for this demo, let's just start that sync and jump into the automation platform. So as we can see here now, I've got a little database here. We've got our code generation platform, but we have no schemas now. So soon that orders schema is going to pop up from Fivetran and populate those tables for us. So while we're waiting for that, to reiterate what we saw in the slides, we're going to build some DDLs via code automation. So we're going to build some staging views, and they're going to sit on top of our Fivetran tables for some governance and some lineage and a CDC mechanism. We'll have a history table, which will be a one-to-one relationship with those views, as we said, very important for automation. We'll have some history views on top of those tables, and this is really optional just to speed up the analytics and give us a current record view of our data. And then we're going to have inserts and merges, and these are our patterns. This is our code pattern we're going to apply to move the data. Obviously, new rows will be inserted, and then we'll merge in the updated rows so we can keep the history of that data. And this is what they look like. So obviously, there's a bunch of views there, and these is a view of one of those views. So you can see here, it uses the information schema. So essentially, no matter what you put in, whether you use Fivetran to load your data or another tool, you will still have this information schema. So this platform will still work from here on out to keep that modularization and three-tier architecture nice and separate from each other. So we have the information schema, and then we're just going to use some concatenate statements to punch out these DDLs. The main kind of one here that you probably might not have seen before is this array ag. So we're going to make an array of the column names, and this is one of the main drivers of the platform. You can see here it's used again over and over. This one's going to produce an ETL hash, very important for our change data mechanism to be able to capture what's changed when our data comes through. So let's refresh this. Hopefully Fivetran, and it has landed our orders table, our orders schema and some tables for us. So now we can run this. As I said, we've got an information schema. We need some structures, which was our second principle. And you can see here, it's going to push out a create view statement, selecting all our column names. And here you can see we're going to build that hash, very important for our downstream process. So I'm going to copy this data. These DDLs. And we're going to run these three. And there we go. We've created 3 staging views. After that, like I said, we're going to create history tables as well. And you can see here, very similar setup using the same array of column names. We're going to do some data type mapping here for some standardization. And in this level, we're going to put our governance columns on. So we're going to know where the data came from. We're going to have an execution date time of when we moved it, what change type we had, so an insert, update, or a delete, our important row hash, and then our CDC2 columns of is current and our expiry date. So similar again, now we've got our information schema. We can just select these, and you can see here it's doing a create table statement this time rather than a create view statement. So again, we're going to grab those and let's run those 3. And before I do that, I always forget we need to create our schema. Cube. And let's create those 3 history tables. Similarly, again, we're going to create the history views, and this is just a view on top of those table where our is current is Y. So this is for our OD operational data store type workflows. And if we're not worried about the is current kind of, the history of our data in certain analytical reporting. So a nice to have and an optional. If you don't want to use it, then obviously you don't need to build this piece. Cool, so let's refresh and have a quick look. And we should have our landing layer here from Fivetran, very nice. We've got our views to get our CDC mechanism on top. We've got our history tables, and you can see here a one-to-one with a nice scheme name persisted through and a solid naming convention, and our views on top of that. So then we'll jump over, and now we can use our third principle of automation, which is our code pattern. So again, as I said, we've got our information schema, and we've got our structures. The third piece is our code pattern. And then as you can see here, we're going to do an insert pattern. And we're going to wrap this in a Snowflake task. So this is how we can then orchestrate this for later on using a nice cron schedule or anything else that's going to kick off a task for us. Very similar again to produce a DDL. And again, for those tasks, so we're going to have a batch. We're going to have 1 batch per schema that we see. So I'm just going to quickly create a master task, and this will be the hierarchy of our tasks. So let's run this. And again, you see a very similar workflow is happening now. Let's grab one of these open and have a quick look. And as you can see here, so we're going to create tasks. We're going to align them after the batch task runs, so we can only schedule the top tasks. Doing an insert statement, and we're selecting everything from our staging view. We're doing some change data capture here for governance and lineage, and we're going to have this is current column for Y and P, and we'll get to the Y and P in a minute. Select everything from the staging, join that to our history view on our current record, and this is our CDC mechanism, nice and simple. If that join on the business key doesn't yield a result in the history table, then we know it's a new row because we haven't seen it before. Or if those ETL hashes that we created in our staging layer are different and we get a join, that we know it's an updated row. If we join and the hashes aren't different, then we know it's the same row, it hasn't changed, so we can exclude it. So I'm going to run one of these just so we move some data across. And we can see here we've moved 10 rows. And then I will create the rest of these tasks for I look at the end. So again, you can wrap these into your CI/CD processes, so all these scripts get executed and you don't have to copy and paste and run through them like we are in the demo, but we're doing this just to see how it's going to work. Great, so we've created our tasks, and then if we jump in here, we have a look at show tasks. We can see we've got our batch task and our 3 insert statements underneath, and we've got some data in our history table. We can see we've got expiry date, nothing's expired yet. We've got our row hash, everything's been an insert. We know where it's come from, and we know what date we've got, and everything is current. So before we run the next one, I'm going to run some data. So we're going to insert and update some data into those tables. Perfect. Let me just make sure those updates ran. Okay, so now we've got some changed data. Fivetran will have finished its historical sync. And we're going to fire Fivetran off again. And we can see we've got some nice statuses here that our historical syncs are finished. So while that's running, like I said, we're going to merge in our changes once we get some in a second here. So how that merge task looks, let's have a go. Very similar again, information schema, pushing out a DDL. And this is the more complicated of the 2 patterns that we're going to see today. So if we grab this merge statement out, we can see here we're going to create a task for the merge and we're going to assign it after our insert task. Very important, our naming standards here to make sure all these link up properly across all our hundreds or thousands or how many tables we're going to build. So we're going to merge here and we're going to see we're joining the history table on top of each other for the current record and our pending records. Now, if you remember, we inserted new records as current because we know they're new records, but our updated records, we insert them as a P, and then we'll go back through here and then make sure that we archive or expire the old record and change the new record to Y. So as you can see here, we're doing that down here. If we do match and we get a P, then let's update it, make it a Y and a current record. When we match the old record and it's Y, then let's expire those records. So we're going to change them to not current. We're going to put an expiry date in, obviously update the timestamp and change the ETL type that we have changed it. So let's go ahead and build these merge statements as well. Copy those out and run them again. Perfect. Let's check Fivetran. Hopefully it's finished loading those few rows through for us. And it has. So as you saw before, we had 10 rows in our column, in our table, sorry. We're going to add 3 more and we're going to update a couple of those as well. So let's run our insert task again. Let me just grab it back out. Okay, we can see we've added 5. So the 3 new columns and the 2 updates as expected. And if we have a check in here again, we can see now we've got 2 pendings and the 3 new columns have flowed through. So now we need to run our merge. These should update to IDs number 1 and 2. These will update to current and obviously number 1 and 2 here have been updated, and we're going to expire those and make them not current. So if we go back to our merge statement and let's run our merge. Okay, let's go back and have another look. So perfect, we can see we've got 2 expired rows with expired date times because they're the 2 updates we've done, and those same IDs now have new current rows. Perfect for historical layout. We've got some data evolution happening here. So great for data scientists now who want to see how this data evolves over time, and obviously a lot of BI use cases also want to see this. If we don't and we still want to do ODS right now, maybe we only want to look at this history later. If we look at the view of the history table, we are only getting those current records. So if we want those, we can hit this directly and go straight out. If we look at our tasks again now, if I'm in the right schema, if we look at those tasks again, we can see we have all those tasks wrapped up for us. All our merge and inserts wrapped into our batch. So now all we need to do, as you can see here, I've scheduled this to run every hour. Fivetran's going to land our data for us. This is going to run every hour, insert and merge it into our history layer. And we have a data platform built in a space of a demo. Hopefully you can see how that's going to spawn out into the wider data platform now if we're doing hundreds of tables at a time. Obviously, you can wrap these into a stored procedure or any other code you have, so these scripts fire by themselves. And this is where we really get into that standardized data platform. So we have standardized lineage, we have standardized code that we know every table is doing the same thing. We have standardized naming conventions and standardized data types. So we have a very good foundation now that we can put some reporting views directly on top of this and really just get straight into the business rules and start servicing some reports. So we have, I guess in this day and age, intelligent systems and intelligent applications. And my challenge or question is, why can we not have an intelligent database that can organically grow, it can update itself, and it can really just unlock the potential of these databases and free up our time for doing these mundane tasks. Thank you very much for listening in. And as I said, all this code is available in my GitHub repository. Thank you very much.